Let's discuss the different biasing configuration. The first thing is the common emitter configuration. We know very well the transistor is a three-terminal device: base, collector, and emitter. So the arrow is in outward direction. So it is known as NPN transistor. So here the emitter is common to both input voltage and output voltage. The emitter is common here in both input to output. That's why it is known as common emitter configuration. The second thing is the common base. Your base terminal is common to both input and output, so it is common base configuration. And the last one is a common collector configuration. So mostly we are using common emitter configuration because it has high voltage gain as well as high current gain. So it is VBB. VBB means it is a base voltage, and VCC means it is a collector potential, VCC. So VBB is less than VCC, or this VCC is very high when compared to this input voltage, because base is P layer and the emitter is N layer. To break the depletion region, we need only 0.7 volt or 0.8 volt, because P type and N type, it forms the PN junction. To break the depletion layer, we need a forward bias voltage of 0.7. If it is a silicon, we require 0.7 volt. If it is a germanium, then VBB requirement is only 0.3 or 0.4 volt. That's why this is a low voltage, then this is a high voltage, VCC. So NPN. So P is connected to positive and N is connected to negative. We know very well emitter base junction should be forward bias. So that's why P is connected to positive, N is connected to negative. And collector base junction should be reversed bias. This is collector and base. So collector is connected to, this is N. This N is connected to plus positive. That's why this collector terminal is reverse biased. To measure the input current, base current, we have connected microammeter, because we have connected only a small amount of voltage. It drives only a small amount of current, so that's why we are using microammeter. To measure the VBE, base and emitter voltage, I have connected a voltmeter in the order of 0 to 1 volt, because to kill the depletion layer we require only 0.7 volt. So that's why I have connected 0 to 1 volt voltmeter. And to measure the collector current, I am using 0 to 30 milliampere, because common emitter provides large voltage gain as well as current gain. If I apply microampere of current in the output side, I am able to get milliampere. So 1000 times the current is amplified. Here also, to measure VCE, voltage across collector and emitter, that's why one terminal is connected to collector, the second terminal is connected to emitter. So to measure the collector to emitter voltage, I have connected 0 to 50 volt voltmeter. It depends upon the transistor rating. Anyway, base current requirement is, it is in the order of microampere, and collector current is requirement is, it is in the order of milliampere or ampere, and this is the collector to emitter voltage. So these 4 parameters I am going to measure through the experiment. So this is an experiment setup. Now let us draw the, and this VBB is a variable power supply and VCC also variable power supply. By varying VBB you can control IB. By varying VCC or this voltage you can control the VCE or IC. Both you can control. So next class we will discuss about the input characteristics and output characteristics of the transistor.